Assalamu alaikum warahmatullahi wabarakatuh. Good morning, everybody. We have now lesson 8 in chapter 4, Introduction to Coordinate Proof. We have used coordinate geometry to find the midpoint of a line segment and to find the distance between 2 points. Coordinate geometry can also be used to prove conjectures, okay? A coordinate proof is a style of proof that uses coordinate geometry and algebra. The first step of coordinate proof is to position the given figure in the plane. You can use any position, but some strategies can make the steps of the proof simpler. We have this strategy for position figures in coordinate plane. Number one, use the origin as a vertex. Use the origin as a vertex, keeping the figure in quadrant 1 or the first quadrant to make them both positive. Center the figure at the origin. Maybe some figures we center them at the origin. Center a side of the figure at the origin. And use one or both axes as sides of the figure. Let's see example 1. Position a square with a side length of 6 units in the coordinate plane. You can put one corner of the square at the origin, like this. Yeah, we want to position a square with a side length 6 units. So you can put one corner of the square at the origin and count 6 units. Count 6 units. So the second point will be at the point 6 and 0 and count another 6 units. It will be 6 and 6 and here 0 and 6. So this is a square. Okay, we position this square in the coordinate plane. Check it out. Position a right triangle with leg length of 2 and 4 units in the coordinate plane. So we draw the triangle. We use this hint that we use the origin as the vertex of the right angle. One leg is 2 and the other leg is 4. Or we can make one leg is 4 here at x and the other is 2. So we have two cases, okay? Once a figure is placed in the coordinate plane, you can use slope, the coordinates of the vertices, the distance formula, or the midpoint formula to prove statements about the figure. Let's see example 2. Write a coordinate proof given rectangle ABCD with A 0 and 0, B 4 and 0, C 4 and 10, and D 0 and 10. We position the rectangle like this. Prove that the diagonals bisect each other. Prove that the two diagonals bisect each other. So we draw the two diagonals now. What the meaning of diagonals bisect each other? It means this point is the midpoint of each of the two diagonals. So in this question, we can use the midpoint to prove that this point is the midpoint of each of the two diagonals. Or also we can use the distance formula. If we know the length of the first diagonal, the length of the second diagonal, and the length of this part and this part and this part and this part. Okay, so by using the midpoint formula, the midpoint of the first AC, we remember that the midpoint to add x coordinate with x coordinate. So we will add 0 plus 4k first x and first x. And first y, which is 0, with the second first y with the first with the second y, which is 10. So 0 plus 10 over 2. X1 plus x2 over 2, y1 plus y2 over 2, okay, which is 2 and 5. And when we find the midpoint of the second diagonal BD, we will find it the same point. So because the midpoints coincide, therefore the diagonals bisect each other. It's a very easy proof. Now check it out. Use the information example 2 at your book to write a coordinate proof showing that the area of the triangle ADB is 1/2 the area of the triangle ABC. Prove that the triangle ABC is a right triangle with height AB and base BC. Because here we know that this is right triangle, okay, because the position of this triangle, its vertex is on the origin, so this is right triangle. We know that x-axis and y-axis are perpendicular to each other, so it's right. And we can use the height as AB and the base as BC. So the area of this triangle is half BH, half B, which is 4, H, which is 6. So half times 4 times 6. So the area equals 12 square units. This is the area of ABC. Now the area of ADB, ADB. We have in this triangle is not right, but we can use AB as the base and draw the height from the point D to the side AB. It will be 2 units. So this is the height, H. By the midpoint formula, the coordinates of the point D, 2 and 3. So the height, the x coordinate of the point D, which is 2, is the height of the triangle, and the base is 6. So the area of the triangle ADB is half BH, or half times 6 times 2, which is 6 square units. Since 6 is half 12, so the area of the triangle ADB is 1/2 the area of the triangle ABC. A coordinate proof can also be used to prove that a certain relationship is always true. You can prove that a statement is true for all right triangles without knowing the side lengths. To do this, assign variables as the coordinates of the vertices. Let's see example 3. Position each figure in the coordinate plane and give the coordinates of each vertex. Rectangle with width m and length twice the width. So if I have a rectangle with width m, it means its width here is m. If we position the rectangle, we put one corner of the rectangle as the origin, on the origin. So the width is 0 and m. And the length is twice this width. It will be 2m and 0 here. So this point is 2m and m. Another one, right triangle with legs of length S and T. So we put the right angle of the right triangle on the origin, which is 0 and 0. Okay, one leg is T, so the leg which is on x-axis, we start with T and put 0 in the other coordinate. And the other leg, which is its length is S, we can write it as its coordinate as 0 and S. So the point which is on Y, 0 on X, and the length on Y, which is S. Remember, don't use both axes when positioning a figure unless you know the figure has a right angle. Check it out. 3, stop the video and try to solve it alone. And then check your answer now. If a coordinate proof requires calculations with fractions, choose coordinates that make the calculations simpler. For example, use multiples of 2 when you are to find coordinates of a midpoint. Once you have assigned the coordinates of the vertices, the procedure for the proof is the same, except that your calculations will involve variables. Remember, because the x and y axes intersect at right angles, they can be used to form the sides of a right triangle. In example 4, given rectangle PQRS, prove that the diagonals are congruent. So assign coordinates to each vertex. So if we have the two coordinates now like this, two coordinates, so this coordinate S is 0 and 0. If the length is A and the width is B, so this point which is on x-axis will be A and 0, and the point which is on y-axis will be 0 and B, and the fourth point will be A and B. Now, write a coordinate proof. By using the distance formula, PR, which is the first diagonal, we know that the distance formula will be A minus 0 all power 2, which is A power 2. Then plus 0 minus B all power 2, which is also B power 2. And QS, it will be also root A squared plus B squared. Thus, the diagonals now are congruent. They have the same results, even we use variables. They have the same results. Okay? Now, check it out for. Check your answer. Now we have a small quiz on this lesson. Okay? And see you in another lesson, inshallah. Goodbye.